How you doing, sports fans? We're going to talk about area today. We've talked about area of regular polygons, and today we're going to talk about the area of some familiar shapes, but you may or may not know how to find their area. At the bottom of the screen here, you see a rectangle. Hopefully you know how to find the area of that. If not, area of every rectangle is equal to the length times the width. So whatever this length is times this distance right here. Length times width is the area of every rectangle. Now above that is a parallelogram, kind of related to the rectangle. You can think of a parallelogram possibly as a rectangle pushed over a little bit. We've got two pairs of parallel sides. That's what makes this quadrilateral rectangle. And the formula for the area of a parallelogram is area equals base times height. So kind of related to length times width. Base is typically this length, and height is going to be measured perpendicular to the base. So it'll be whatever this length is times whatever that length is. And you might imagine a time where we have to come in here and calculate this height, maybe using some angle here and some trigonometry. But today we're just talking about the formulas. So area of a parallelogram, base times height. Area of a rectangle, length times width. This next shape is a rhombus, and you can find the area of rhombuses using their diagonals. So you'll notice I have a purple diagonal and a blue and a green diagonal. So we'll call one of those diagonal 1 and one of those diagonal 2. And so the formula for the area of a rhombus involving the diagonals, it's diagonal 1 times diagonal 2 cut in half, or divided by 2. So it's half of diagonal 1 times diagonal 2, with diagonal 1 being this guy and diagonal 2 being that guy. And now they're no longer purple or green. This shape is a trapezoid. To find its area equals base 1 plus base 2. After we add those together, we multiply by the height, and then we divide by 2. So we might call this base up here base 1, that is this distance, and this one down here could be base 2, and then the height is the distance between those bases. So base 1 plus base 2 times the height divided by 2. So here you see another familiar figure. You might imagine a windy day in March, and we've got a kite right here. So the formula for the area of a kite is pretty much the same formula as the area of a rhombus. It involves the diagonals. And again, we have the green diagonal and the purple diagonal. One of them we might call diagonal 1. The other one is diagonal 2. And the area of the kite is the product of the diagonals divided by 2. Here we see two pretty familiar shapes. We got triangle. Area of a triangle is base times height divided by 2. So maybe this is the base and the height would be right there, measured at a right angle. And then we have circles. We talked about circles a week or two ago. The area of a circle is pi times the radius squared. So there's your radius. And that, my friends, is area talk. So now let's go to Moodle and look for Module 12. It's called Polygons, and you'll find 3 Word documents in there. Practice 1, Practice 2, Practice 3, and those have quite a few practice problems on area of different shapes. So let's open those up and get at it. I'll be wandering around to help. Thanks.